Anybody want to take a guess what you get when you combine an elephant with a fish?
You get an elephant.
Elefish?
Alligator. You get a
You
cat.
get an elephant and a fish.
No, you get a cat.
No, you get swimming trunks.
Oh, yeah.
Oh, I get it.
I know
Literally,
it's
the
better.
fish swims and the
Yeah, you get swimming trunks.
It's only funny because it's not funny.
That's our point.
Totally.
I mean, you made it look fun by saying that.
You live by that. You live by that. I bet you suck it
That's one of the best all-time dad jokes right there.
out. You like
That was pretty funny.
All right, so at top of the C4 page, you got a spot for some warm-ups. So let's do these two warm-ups. Turn these two English expressions. I had to make sure there wasn't any more down below. Turn these two English expressions or English sentences into math expressions, please. Okay?
Oh, yeah, Mr. Lidmar.
Mathematical operation going on in number 1. Add, subtract, multiply, divide. What's our mathematical operation? Subtract. What did we choose or use to represent a number? X, okay? Because it means a variable, right? We can represent a number with a variable, so let's call this X. So my choices are 14 minus X. How many people, show of hands, wrote 14 minus X? Okay? What do you got, Colin? You went with T as your variable, right? Yep, you went T minus 14 because it said subtracted from a number. So this one is, in our case, X minus 14, or whatever letter you chose, minus 14. Okay? The key in that one was this one right here, from. Okay? Because we're subtracting from the X. Okay? Operation or operations in number 2. We got an addition of what? Right, so this is going to be addition. What are we going to call a number? X again. Okay, so we are adding the sum of X and 3. How do I say that? X plus 3. Okay, so that's that part. What about this other part? What operation is going on in the rest of them? Not addition, not division, it is multiplication. Of, remember, of was one of our multiplying words, okay? So we're going to go 1/2. Since there's 2 operations now, what do we need to add? Parentheses. Yep, so we're going to put the X plus 3 in parentheses, and we're going to put 1/2 right in front of it. Okay. Questions on either one of those? All right, let's get into some notes. So, how do I know an expression is fully simplified? What was that? Because you can turn your page over and go to the page right before it. Actually, you don't even have to turn your page over. It should be right on the page right before it. We get Nora. What about the like terms? We combine all of our like terms? Yeah. So it's an expression is fully simplified when we combine all of our like terms. They are. That's why I told you to look back at yesterday's notes too. Okay. Like terms have what? Same variable. and same exponents. Yep, gotta have both because it is an and statement. Okay, that this word right here, and, means that both of those have to be true in order for it to be like terms. So x squared and x are not like terms. Okay? Because they have the same variable, yes, but they don't have the same exponent. X squared and y squared are not the same terms. They don't have the same variable, but they have the same exponent. Okay? So we have those two. Instead of what a coefficient is, which is the number multiplied by a variable, where do I find a coefficient? The number right in front of a variable? Yep. Okay, so a coefficient is the number in front of a variable. Write that down too, because I think that is an easier way to know where to find it. Okay? The number that's in front of the variable. How do we actually, and make sure it's not down there, no, it's over here. How do we actually combine like terms? What's our process? Put the like terms next to one another? Yep, okay. So we got to rewrite our expression. We put the like terms right next to one another. And then what do we do once we got the like terms next to one another? Add or subtract the coefficients, and what happens to the variable? It stays the same, okay? Yesterday in my classes, we used the pencils as our explanation, demonstration, if you will. So if Jazz has one pencil, and I give her 3 more pencils, those pencils didn't change. They didn't suddenly become books. They stayed pencils. Okay? Just the number of them changed. Okay? Same thing if I take all 4 pencils away. Now I got 4 pencils and Jazz got none. Okay? So we add or subtract the coefficients, leaving the variable the same. All right? Let's do 1 and 2. How many you got? 6? 6 of them to do. Let's do 1 and 2 together. Then I want you to do 3, 4, 5, and 6. Okay? What are the two? Give me. I gotta have the breaks here because I don't want to give it away in the actual problem. Give me a set of like terms in number 1. 14k and negative 3k are alike. This one right here and this one right there. And remember that sign in front carries along with it. Those are like terms. Is there another set of like terms? 10 and negative 2 are like terms because constants are automatically like terms. Okay? If you have 14 eggs and I take 3 eggs away, how many eggs do you have left? You've got 11 eggs left over. If you've got 10 pieces of bread and I take 2 pieces of bread away, how many pieces of bread do you have left? 8. In number 2, give me a set of like terms. A and negative 3A would A, there it is, and negative 3A. Give me another set of like terms. Negative 5 and positive 1. Then you got to write down whatever's left over, right? Because there's nothing that's like with the B, so we just have that still in there. We don't just lose it because it doesn't have a like term. Okay? If you've got one Kit Kat and I take 3 Kit Kats away from you, how many Kit Kats you got left? Negative 2 Kit Kats. So this would be negative 2A. If you've got negative 5 Butterfingers, and I give you a Butterfinger, how many Butterfingers do you have? Negative 4. And then that negative 2B comes along for the ride. Okay? Now, as long as the order or the coefficients stay the same, you can write it in any order. Okay? As long as the coefficients are the same. You now try 3, 4, 5, and 6. Okie dokie. So we got a 6m and we got a negative 4m. That's these two. Another way of doing it is you can cross out after you rewrite them. You can cross them out too.
Why is that 2? Why is that number 2?
I don't know. It's number 2.
Yeah, that's
Right.
number 3.
So then we've got plus 7n, but I got no other n terms to go along with it, so that one's there. And then we've got plus 10 minus 8, because constants are the same. Okay? 6 pens, I take 4 of them away. That's going to leave me with 2 pens. Nothing combines with the 7n. 10 books, and I take 8 of them away. That's going to leave me with positive 2 there. Okay? Again, as long as the coefficients are the same. So if you wrote 2m plus 2 plus 7n, that's fine. 7n plus 2m plus 2, that's fine. Okay? X squared, there's another x squared term there. So that's going to give me 2x squared minus x squared. 3x and x. 5 and negative 7. 2x squared minus x squared. If you have 2 of something and I take 1 away, that leaves me with 1. If you got 3 and I give you 1, that gives you 4. If you have 5 and I take 7 away, you get negative 2. Thumbs on those 2. Thumbs up, you got them both right. Thumbs to the side, you got one of them right. Thumbs down, you got none of them right. Okay? Those people that didn't have thumbs up, any questions on this one, on these 2? Yes, 1x squared. Yep, so what Nora was asking is if I put a 1 in front of there, that's fine. Yep. With or without the 1, that's fine. Okay. We've got a W and a minus 5W. So that's that one, and that's that one. We've got a minus G plus 8G. That's that one, that's that one. Those all go away now. Used all my terms. If you've got 1 of something and I take 5 of them away, that's going to be -4 of that something. If you've got -1 of another thing and I give you 8 more, then you have +7 of those. So you got -4 plus 7g. 14 is an m, plus m is an m, so that's 14m plus m. Then we've got -10k minus 3k. Then we've got +6. 14, and I give you 1 more, that gets you 15. -10, and I take 3 more away, that gives you -13, and 6 is just 6. Thumbs on these two. Thumbs up, you got them both right. Thumb to the side, you got 1 of them right. Thumbs down, you got them both wrong. Those people that got some wrong answers, what did we screw up on? Just as a FYI for everybody else, maybe some other people won't make that mistake then.
I thought was subtracting 10 from 3.
Okay, right. So because remember we're at negative, subtracting is going down, which means we gotta go down 3 more. Yeah. You guys had it. Anybody else that made a mistake willing to share? Okay, so for today, in order to get today's assignment, okay, what I would like, or what I have for you is I have an exit ticket for you. So when you get done with this, you can come up and you can get it checked by me, and then I will give you the homework for today. Okay, we'll probably finish it before I get them all handed out.